now we've got our panel solutions for the cold food chain. We've got 4 panelists. We have about 40 minutes to cover different perspectives, different technologies, different natural refrigerant solutions from different experts. They each have about 7 to 8 minutes, and there will be time for questions at the end of the panel from the audience. So first off, we have Naimul Islam, who's a senior engineer of Arneg Oceana. He has 34 years of industry experience, and he is going to tell us a little bit about what they've been doing over in Arneg, specifically around CO2. So Naimul, over to you. We're having some connection issues. So who is online right now? I see Michael and Ezekias. Maybe we can start with Ezekias because you're second in line. So to not lose any more time, I propose that we start off with, we go with Embraco. And then when Naimul and Craig join, then we'll go back to the schedule, okay?
No problem.
So, Ezekias Pereira, I hope I pronounced it okay.
Yeah, very good.
Is a sales senior manager for the Asia Pacific region, global appliance that now own Embraco, and he's responsible for the Embraco portfolio for the Asia Pacific region. So he's going to update us on what Embraco has been doing specifically around hydrocarbons. And what they're seeing coming down the line in terms of technology improvements. So over to you, Ezekias.
Okay, Mark and the Shekel team, thank you very much for the invitation. I'm very glad to be again in Atmo event. It has been great.
I've been a few now.
Yeah, probably my 9th one. all of the Atmos in Asia and Oceania, I'm always together. So thank you very much. It's always a pleasure to share a little bit about our experience with natural refrigerants. It's not news that Embraco supports the natural refrigerants. We do believe that's a real refrigerant for the future. So I hope you enjoy my presentation. It'll be quite short because we need to leave some time for the discussion. How to push to the audience?
You want me to push them for you?
Yes, please.
Yeah, okay.
So this is the short agenda. We can go through the next slide. That's true. We are suffering with global warming. Recently here in southern Brazil, where I'm today in Joinville, we had heavy wind by a tornado. Not common in Brazil. Brazil is a very calm country in terms of natural disasters, and we lost a lot of houses, we lost some lives, and now is winter, and we shouldn't have this kind of problems here in Brazil. I have a picture in the slide from Pakistan. That's a flood where we see a mosque just underneath the water. And in that chart in the center, we can see that the research says we are going to see 2 degrees increase of temperature in 120 years. I saw the presentation from Ian, and he was saying that only the HFC would be responsible for 0.5 degrees of that increase. That's quite a bit in a short period of time. And in the opposite direction, when we talk about financials and results for the companies, we see a huge increase in the price of the HFC refrigerants. Since a few years ago, we have some bans and tax increase to reduce the usage of these refrigerants, pushing towards the natural refrigerants. Okay, Mark, I learned how to pass. Actually, I remember. That's a timeline. I should start with natural refrigerants, and then we human beings, we discovered the CFCs. We suppose that those refrigerants were the best, and then the HFCs, and so on. Now we are in a debate of going or no to mixtures and natural refrigerants. And again, we are supporting the natural refrigerant options, and I'm going to show you better why we do believe those are the best options. Natural refrigerants, they have very low impact to the environment. They are cheaper. The compressor works in a much lower temperature. The compressors are much smaller, and we have much better efficiency. You could see that I speak few times in just a paragraph. So, of course, we have some trade-offs. They may be flammable, but everybody drives a car with gasoline in the tank. And I believe that's much more dangerous than having a refrigerator with 40 grams hydrocarbons in a kitchen. And how to compare these refrigerants? We have a lot of engineers. We have more than 500 engineers working in our research centers around the globe. And we tested in a very systematic way 5 different refrigerants. We tested the 404, and we tested the mixtures, A12, 1, 2, and 3, and we tested the R290. And the efficiency is much better with the HFC, the hydrocarbons. And the compressor temperature is more than 10 degrees. The same kind of compressor, the same cooling capacity, you have 10 degrees difference. It's not negligible, okay? From the compressor side, we are the manufacturers of the heart of the refrigeration system. We can say that 10 degrees is a lot of temperature to increase and to save energy in a compressor. We have some challenges, especially in Australia and New Zealand. We don't have much norms, codes. And we are progressing towards the usage of these refrigerants. In the next steps, we have other countries progressing, and we see customers in Australia and New Zealand interested in using this kind of refrigerants. Actually, we already sell a few of compressors to the market. And in our opinion, in the range of self-contained and small commercial appliance, the R290 is not just a trend. Is the reality that's coming true. A little bit of propaganda for us. So we have a very wide portfolio range, since very teeny compressors for small chocolate coolers up to cold rooms, walk-ins, and all the medical equipment. We can have cryogenic compressors, all with natural refrigerants. Not forgetting that now, being part of Nidec, we also sell the motor for laundry. I did my part, Mark, you know, right? And talking about the real experience of our customers, just changing the compressor, Okay, we moved from a F series to a VES series. The difference is about 5 kilos. And 20% energy reduction. In a country where 70% or 75% of energy is generated by coal, like Australia, I think 20% difference can make a difference, right? And when we go to an under-counter, we could see 32% difference. We changed it from a FFU to EMC compressor. It's not a variable speed. It's a on-off by on-off compressor. And the difference, again, is huge. It's 32% reduction. Even in a country where we have sustainable electricity like Brazil, 90% is hydroelectric, we believe 32% is a lot. And when we compare to the DOE in US, the new regulations, that's the way to go, okay? That's what I brought for today. I hope you have some questions and I will be able to answer them. Thank you very much.
Thank you, Ezequias. We'll allow for questions at the end of the panel.
Okay.
I'd like to give all the speakers time to present their slides, and then we'll make a little bit of time available for all. But I guess you'll get a question around the 500-gram charge limit change. But don't answer that right now. Keep that for after. Okay, so next up, we have Naimul Islam. He's now with us. Welcome, Naimul. Senior engineer of RNEG Oceania, has a wealth of experience in the industry, and today he's going to talk about CO2 and specifically what RNEG has been doing with transcritical CO2. So over to you, Naimul.
Thank you, Mark. Thank you, everyone. I'm Naimul Islam from RNEG Oceania. Today, I'm going to talk about how RNEG World promoting natural refrigerant and providing complete solution of transcritical CO2 to the entire wider range of our customer. I also will talk about our specification for transcritical CO2 that is under installation at Thornley's Supermarket Distribution Center here at Sydney.
Good.
And at the end, I also will talk about highly energy efficient refrigerated Santiago air system that runs with no defrost at all and at positive SST. RNEG has a complete package and offering full solution of CO2 systems to cover the wider range of our customers, from small metro to large supermarket. RNEG has designed 4 different type and size of transcritical CO2 model. The simplest one is global, and it can cover 14 to 38 kilowatt medium-term applications and 4 to 10 kilowatt for low-term application. The mini booster model, it covers 24 to 94 kilowatt for medium applications and 7 to 20 kilowatt for low-term applications. Our booster model is suitable for medium-range supermarket. It can cover from 91 kilowatt to 240 kilowatt for medium-term applications and 17 to 53 kilowatt for low-term applications. And our booster XL model, which is very suitable for large supermarket, the capacity between 220 to 460 kilowatt for medium-term applications and 45 to 120 kilowatt for low-term applications. The simplest one and smaller size one is global transcritical systems. The main feature for this one is variable speed drive for both compressor. It has a oil separator. It has K65 for high pressure burns. And it has also regenerative heat exchanger. And the mini booster model has the parallel compression technology to improve the energy efficiency. The booster system has parallel compression as well as ejector technology, and it has a liquid receiver and other features. The Booster XL, as I mentioned, this is suitable for large supermarket. It has parallel compression and ejector technology, as well as it has a double oil separator and the double liquid receiver. Arneg Oceania first installing now transcritical CO2 system at Thornley Supermarket Distribution Center here at Auburn, Sydney. In fact, we have almost finished the installation, and we are expecting to do the commissioning within 2 weeks' time. Thornley Supermarket Distribution Center has 2 cold storage, one for the freezer room, another for the normal cool room. The dimension of the freezer room is 12.5 meter width, 16.5 meter length, and 9.5 meter height. And the cool room, the dimension is 5.5 meter width, 17.7 meter length, and 9 meter height. Our customer Thornley looks for a future-proof solution for cold storage, which minimizes the risks of future synthetic gas cost increase due to phase down. And Arneg Oceania has offered a system with variable ejector technology, which can give the best energy efficiency in Australia warmer conditions. We have offered a system which has the capacity 110 kilowatt at a low temperature at the freezer room. It has a VSD operated 4 compressor, Dorin compressor, 80 horsepower. And the medium cool room, 45 kilowatt, VSD operated 3 compressor, Dorin 102 horsepower. And the parallel compressor is a Dorin model and 34 horsepower. We have used the technology of variable ejectors. It's a Carroll variable ejectors and Carroll controller. The indoor units for freezer room and the cold room for Modin. And the gas cooler we have used from Modin, and the capacity of the gas cooler is 349 kilowatts. In the pressure side, the discharge side is 120 bar pressure, and then the liquid and the suction side is 60 bar. Arneg direct installation around the world. Arneg is almost reaching 1,000 direct installation around the world. Some installation were carried out in tropical area of Central America, which gives us enough confidence to work around tropical area in Australia. As we know, the operating cost is a vital rule for financial analysis of a commercial refrigeration system. So the refrigerated cabinets or any component, refrigeration component, is the main denominator that actually causing operational cost. With this view, Arneg World has developed a highly energy efficient refrigerated display cabinet, Santiago air system, that runs with no defrost at all at positive SST. Arneg has supplied a good number of air systems in Queensland, South Australia, New South Wales, and Victoria. our Santiago air system has been successfully operating almost 2.5 years in Australia. So this Santiago air system is not only optimize or reduce the operating cost, which is OPEX, but also it would extend the shelf life of the product because of no defrost strategy. Thank you so much.
Thank you, Namal. We will have questions for you at the end of the panel. I definitely have one, and I'm sure we'll have some more from the audience. So thank you, Namal, for that. Very interesting. Next up, we have Craig. So Craig is owner and managing director of CyberChill Precision Refrigeration, an Australian-based company. Who's going to talk to us a little bit about the commercial refrigeration applications that they have designed and developed for the food service industry here in Australia. So without further ado, over to you, Craig. Are you there, Craig? We can't hear you.
Sorry, my apologies.
No problem, no problem.
Okay, so yeah, thank you for inviting me to this. It's just great to be a part of this, and so far it's been so nicely run today. CyberChill has we've got a number of world-leading designs in our portfolio that we've done throughout the years. I've listed a couple there, so you can see the Cool Can was one of the first ones. We've got a flip fridge, which is a fridge that can be inverted to either a top or a bottom mount fridge. So it's just some of the designs. So it was a natural progression for us, if you like, to try different refrigerants, which we tried or first went into R290 about sort of 8 years ago. And we were also doing 1234ZE at the same time. What we've done is, if you take, so at the moment, everything is around R290 refrigerant. It's a natural progression for us. It's an excellent alternative to 134 and to 404. We've covered off before, but non-toxic, free of ozone depleting substances, and a very low GWP. It's climate friendly. That immediately lends itself well to, if there is a leak in the system, it's a natural refrigerant and it's straight into the atmosphere. In one of the slides that I'm going to move on to is you can see here we've got a smaller gas charge which is required. We use smaller compressors. As a result, they're very energy efficient, and it's a very efficient type of refrigerant, so we tend to reach our set temperature a lot quicker. And in the UK and in Europe, everybody was pushed. It became mandatory to go to the new MEP standard. That was a good thing in terms of there were certain sort of energy performances that the cabinets had to achieve to become either an A-rated or all the way down to a G at the time. This was a good thing in terms that it forced the manufacturer to go back and look at what refrigerant they're using, look at the ducting within the refrigeration, how their refrigeration runs, and in terms of insulation, door gaskets, et cetera, et cetera. So the fridge was made actually more efficient to achieve the MEP standard, which is now coming into force into Australia. They're using the same test standards that they used in Europe, and that's becoming mandatory from, they're talking about the 15th of August next month, but it looks like it might be pushed out by another few months. But nonetheless, it's still good for Australia in terms of this new MEPS rating. What that's done for us, it moved us onto R290 to enable us to achieve the A rating. So it was to enable us to achieve the best possible star rating that we could for the cabinets, and using 134 and 404 didn't quite cut it. So that was the main driver And then obviously you've got all the other benefits, obviously, that it's you've got things like 404, which has been slowly phased out in 2020. You've got 134, which has been phased out in 2022, or phased down rather, in 2022. So this has just been a natural progression for a manufacturer. Our challenges, what we found is, whilst I said we introduced this about 8 years ago, but we found that we couldn't introduce it fully into Australia and New Zealand because we didn't have the technical support. And that came, we pushed through to our service technicians around the country, but many of them weren't certified to do it or hadn't done the training. There were a lot of bigger type installations that weren't quite ready for R290. And as we know, there was quite a bit of sort of industry scare tactics in the first part. And the way we got around that was we would talk to our customers and just say, if they went to their fridge at home, it would be charged with R600. So they're busy living with a hydrocarbon fridge in their kitchen every day. This is just a commercial application. It's the same thing. There's certainly a lot of testing and rigor around it. And obviously we guided by guidelines for the government. So what we found is we tend to drive the technology. If we waited for the service technicians, we wouldn't got where we are today. So we tend to drive the technology, which is what we've done. So we went to the market and said, this is what we are doing. We're using R290. It's going to future-proof your system. It's going to future-proof your fit-out. And it's a natural refrigerant. So you've got a lot of customers that want to be a part of that. They want to be a part of the green message. It helps them to fly their corporate responsibility banner. So it was a win-win in terms of doing this, or at least using this approach. We then, to support that, we carry a large selection of R290 compliant spare parts, and that'll be fan motors and compressors, etc. So that allowed the technicians then, I guess, a bit of peace of mind to go ahead, do the transition, become certified, and start installing these type of applications, or at least servicing these type of applications. So what we found is we went to some of our customers and we started telling them, or passing on the message as to what we're doing. And the moment we explained about legislation, about the MEPS and the GEMS legislation, about the refrigerants being phased down, we found many of the blue chip type restaurants, and right the way down to the smaller cafes, get on board very quickly, just simply with a message. It's just, I guess it's knowledge from not knowing to knowing. And everybody tends to want to do the right thing. So people don't have a preference as long as the fridge works, as long as it performs and gets down to temperature and holds their food at a safe temperature. Everybody started getting on board. When they start hearing of some of the stories that happens in Europe, where some of the old refrigerants or some of the old outlets that are still on old refrigerants have to be certified once a year, there's a cost involved with that. They tend to want to shy away from that. So what we found is we went to our customers, started supplying R290, and now they're on board with all their fit-outs. So that message has gone through to a number of installations around Australia, and we've started talking about energy efficiency, thicker insulation, holding the temperature, the core temperature longer, etc. So that's where we've gone. So I've got a couple of installations here just showing. This was one that we'd done. So it's a Memento Hospitality group that have a number of bars and restaurants around Sydney. And they've actually come to us now and said, for the next one, make sure it's R290. And they've got one that's happening in the Greater West Sydney area. And again, they've insisted on us. So this is the last 2 or 3 installs just from them alone that they've insisted that it be R290. So for us, it's been a positive message just by communicating that to our end customer. And we've got far more of our service technicians now on board servicing R290 than what it was 8 years ago. So for us, it's a positive message, and it's a positive way forward. So that's it.
Thank you very much, Craig. We'll have some questions for you in a few minutes, so please stay online. Great to have you. All right, so next up we have Michael Bellstedt, who's the CEO of the Minus 40 group of companies, very well established in the industry in Australia and beyond. I've known Michael I don't know, 10, 15 years now. He's worked with all the natural refrigerants, but today he's going to talk mostly about ammonia and CO2 and the different applications that they're being used at, and one could argue increasing competition between these two solutions. So it'll be interesting to hear his perspective. So over to you, Michael. I think we're having an issue with your microphone, Michael.
Perhaps I should unmute it. That might help.
Okay, now we can hear you. Right.
That's the classic modern problem, right? Okay. All right, I'm looking at this from a advisor's perspective, not as much from a supplier's perspective. And that is classically our position in the industry is one of an advisor. So we get to choose and we get to advise, and we can jump from one solution to another. And that's kind of the benefit from being an advisor. But approaching it from, I guess, the helicopter view, in our industry classically has been a very dichotomous industry. So we used to have, and that's why I'm starting from this one, very clearly, the big dirty boys being the ammonia industry, and then the small clean guys with the Freon systems. That was classically the industry we were in up to now, and it was very dichotomous. You had very few operators doing both. That has changed. That is the essential point, and we now have more tools in the shed that we can work with. So as you've heard from many other speakers today, ammonia has become smarter, it's become safer, it's become cleaner. We have low charge ammonia, which is a great thing. There are ways to make ammonia much lower on maintenance, so eliminate oil drainage, and the controls have been fantastic. So we can even enhance ammonia beyond what we used to be able to do. It's fantastic. At the same time, carbon dioxide has jumped up and started displacing HFCs, as we've also heard at great extent today. And I'm obviously focusing from the industrial perspective. So, Craig, with all due respect, I'm not covering hydrocarbons in this presentation. So, and then finally, we've had heat pump technology recently arise, and that was also covered by the speakers today. But both ammonia and carbon dioxide, with differing solutions, are great tools in the shed. So that's where we're at. And that leads us to solutions like this, which is a recent project we completed as advisors, where a very large low-charge ammonia system was used to achieve a very high cooling of glycol and water to displace umpteen Freon systems. So this was a large project in Brisbane that we were very happy with. At the same time, we see carbon dioxide popping up and giving us similar options. This is a case very similar to CO2 applications that others have spoken about. But in this specific case, a very large use was made of heat recovery from the system. So heat was recovered both from the high stage compressors or the medium temp, as well as from the booster machines to integrate the CO2 system with other requirements on the site. So what are we seeing now? Well, we're actually excited. It's actually very exciting. Instead of having this dichotomous industry, we now have ammonia sort of encroaching down onto commercial level. Applications that used to be strictly Freon are now, threatened by ammonia. Conversely, and this has been said by other speakers too, we have ammonia pushing up in the other direction. Not ammonia, carbon dioxide. So there are very large CO2 applications going out there, and depending on whether you're a CO2 or an ammonia system supplier, you'll argue the one way or the other. And but then together they make a very good solution for an integrated system. So, a year ago, our local CCM even had an article about that, the battle of supremacy, CO2 versus ammonia, and that is totally apt. And it's good for our industry. We should see that it's good for our industry that we have competing solutions, and it's good for an advisor like us. We can choose which one actually works best for a specific application. Now, energy efficiency is also the key driver here. So we have, up to now, energy efficiency has been all about using less energy, which means achieving more kilowatts of cooling per energy input. But it's also just as much about reusing energy. So energy that you would instead put out through the cooling tower, put to use. And then it's also about integrating energy systems. And that could even include energy generating systems like solar panels. And that takes us to food processing, a classic industrial application where we have a whole range of temperatures that happen in a food processing plant, all the way from cooking, which obviously happens at 100 plus, sterilizing at 80 degrees, scalding at 70, wash down at 60, hand wash at 40, process cooling at 20 or 30, air conditioning at 10, chilling at 0, freezing at -20, and blast freezing down to -40 perhaps. So classically, the bottom few are traditional refrigeration. But what is happening now is that we're doing the whole lot. So thanks to carbon dioxide, we can go all the way up to sterilizing, getting reliably 80, even 90 degrees water out to our clients. Scalding is also possible with that. Wash down and hand wash has been within the ammonia's range for a long time. And of course, we can do all the others. So the whole idea now is to integrate that whole thing. Integrate that and then get the net lowest energy for the site. And even better, find a way to bring solar PV or other forms of regenerative energy to work with this with some form of thermal storage. So what is the future? The future, I believe, the industrial commercial distinction will largely disappear. We will not have practitioners just doing one or the other, but it'll be much more diffuse. I think carbon dioxide, ammonia, and secondaries are going to be a future toolkit, and I'm referring to industrial refrigeration. Integrated systems will be the norm. The only way you're going to get payback on a system is by integrating. And total life cycle costs is what's going to sell natural refrigerant systems, nothing else. So that's me. Thank you.
Thank you, Michael. Very interesting future. I like it. Okay, we've got. We'll take a few minutes. I know we're close to the coffee break, and I know that we have an interesting panel in 10 plus minutes. So we have a few questions. I'd just like to throw them out to give our panelists a chance to answer. So the first question is for Craig. We have. Let me read it out. Craig, so do the technicians hold a J74, J175, and J176 hydrocarbon competencies under the refrigeration training package?
I'm sure that's what it is. I don't know the exact number by heart because I don't have it to hand, but whatever it is, it's the compliancy for hydrocarbon. That's what we insist on. So our service department, before they work on our equipment, have to hold the relevant certification. If that's the certification, then that's what it is. So, yes.
Okay, thank you. Next up, we have a question for Ezekias. Whilst I'm an advocate for hydrocarbons, the industry needs to support change in the training package for Australia. How are the manufacturers dealing with this? What support is the industry giving to RTOs, to qualified technicians in hydrocarbon training? Question from Glenn. Over to you, Ezekias.
Hello, Glenn. We are in Australia and New Zealand together with our distributors, and we trained them to give support to our customers and to the industry overall. So if any support is needed to train the technicians, you can count on us. And now with this pandemic situation, you can count on our distributors. We have several webinars. I myself, I'm part of the training group, and we can schedule a webinar and make it from far, from here from Brazil or from Europe. We can choose one training session to the technicians, and locally with this distributor we have in the country, we can work together to support the industry.
Okay, thank you. Great to hear that Embraco is doing their best to support the local industry. Next up, we have a question from Mike Nolan. A very interesting one, actually. First time I've come across this question. I'll give that to Michael. Okay. So, would it be possible to have a very simple high-level blockchain or QR code for all food to track? 3 or 4 key elements, info that's available to public access, like the main refrigerant type in production, used in storage, used in transport, and main source of electricity, whether it's renewable or fossil, energy efficiency, star ratings, etc. Really great question, actually. That would be awesome. I mean, if Michael wants to take that, but if the others want to react, feel free.
I can just agree that it'll be awesome. But Ezekias, if you have a comment about that, because I can't go into the detail of it, I think it's a great thing to have.
I have a recommendation. You can have a look on the back of the system. You can take the compressor code and search an Embraco catalog. And you are going to find the efficiency level and the refrigerant type, oil, all kind of information. You can also download the Embraco app.
So I've seen that on other manufacturers or compressor manufacturers. I've seen these QR codes. I have seen that, and it's great that you're doing that. Right here, it's a level above. It's more looking at the system and the whole value chain. That, to my knowledge, that's not really been done in the industry, unless others have seen that, and I wish to comment. But it would be quite valuable in terms of creating transparency and accountability.
Mark, sorry, Michael. Mark, that is one thing that that the fridges have to have, and part of that MEPS and GEMS rating that I was speaking about, we have to have, or rather, we're going to publish every one of our cabinets on our website. So any customer, who takes a particular model would be able to go onto the Cybertool website and see what the star rating is or what the energy rating is of that fridge, and that's part of So this is only one part of that, but I think for this to work, it's a number of organisations that need to get together. We kind of bound by what the Australian energy departments are doing and New Zealand energy departments are doing, and within that, this is getting into transport and other things. So, as you said, good question, but how do we tie it all together? What we can say from a manufacturing point of view, yes, you will be able to check our cabinet and see what the energy rating is.
Okay, thank you.
Now I understood. Would be like a seal, like a non-freon food, right?
Yeah, like a certification.
Yeah, it's kind of, in a way, not a certification. Well, yeah, you could argue that, yeah. But it's more looking at the whole perspective. It's actually getting closer to the clean cooling that Toby Peters was mentioning. This is a more practical application of that. And you could scan that very easily, and you can go into a store or wherever you are, and then scan it, and then you would see very much what's the carbon footprint of that system. That would be awesome. I'm guessing that's what Mike was getting at. All right, I'd like to throw a question to Namel because he hasn't had one yet, so I will ask you one, and then we'll close this session. Before I get told off by my colleagues that we're running out of time. Sorry, Franco. The distribution center that's going online in basically 2 weeks' time, Namel, correct me if I'm wrong, is that the first DC that you've done with CO2?
Yeah, this is the first installation we have done.
All right, so that's already a big thing for Arneg, right? But what were the challenges? A couple of challenges that you had to convince that customer, Tongli, to actually go with CO2, because that's a new technology, and from the technology I saw, the specs that you were putting, that's a pretty full-blown system. So I'm guessing cost was one, but were there other challenges that you were facing?
The technology we are providing here is, because during the summertime we have climate conditions, and which is not actually favoring for CO2 applications. So we actually has offered a latest technology for variable ejector system, as well as the parallel compression. So these two technology will offer or will end up with better energy efficiency and as well as a robust system. That will ensure us the system will be robust and as well as energy efficient in the warmer conditions.
Okay, what I was getting at, and then was more beyond the technology itself and proving it can work. Were there other challenges that you were facing to introduce this new solution to a customer like Tongli?
Oh, probably that can answer the marketing people, because as far as the technical thing is concerned, I do not know what are the challenges they have faced so far.
Okay. Okay. All right. No problem. Well, then I'd like to give a round of applause for all the panelists. Thank you for taking the time this afternoon to join Atmosphere Australia.
Thank you.
This one we've done. It's the first time we're going online. Obviously, we don't really have a choice given the pandemic right now, but I hope that you're all learning from this and exchanging, and it's helping elevate the discussion around natural refrigerants. So thank you all for participating. Now we're going to have a coffee break, and then I will hand over to the next moderator and panel that will be on air conditioning. Thank you very much. Bye-bye, everyone.
Thanks, Mike. Thank you. Bye.
Thank you, Mark. Good luck with it all.